2019 question B2 here, folks. And so in this question, we're given the elevation and plan based on a bridge in County Louth. And it says the curve ABC is a parabola in elevation with the vertex at B. Draw the given elevation. Well, I've gone ahead and done that. I don't think at this stage of your drawing career you need to see how to draw a parabola. Part B, the curves DE and F and PQS and plan are branches of a double hyperbola. The vertices are at E and Q. The construction for the portion DE of one branch is shown. Okay, and then it says G or HLG is a straight line. Draw the given plan. So again, because you were shown how to do it, I drew in this side. I just mirrored it over and then I mirrored it down. Okay, to do it. So I have all that done there. So the next part then, we need to do some finishing off here in this question. So we need to draw in that, first of all, the line HLG. Now to find G, if we come up to this second point here, so this was broken into 5 equal segments, and if we come up to that point there, we can draw a black line. We can draw it heavy as far as here. I'll just do it lightly there for a moment, and we can do it heavy back here as well. Now we can take that measurement and we might as well do the south side as well while we're at it. And we're not sure the hidden detail yet, so I'll just do that light for now. Now that finds us, from doing that, that gets us point G there. And we have L already. So we can put down our set square, and we can draw a line from G going through L onwards until we hit that line there, and that will find us H. We just take that measurement now and we mirror it down. And we have those points now on all 4 corners. Okay, so we'll finish that off in a moment. So the next thing I want to do then is I want to come over here on the right hand side, and I'm going to draw in that line now. So again, just a matter of mirroring over all these points. So I'm going to mirror over point L. And we can do that on the bottom side as well. And we'll mirror down this point G. Be there, and we do the same on the other side, and that's our point there as well. So that's our straight line there, and the same down here. Okay, now we have, if I just call this point X, we have G and X. The last thing we have to do there is we've an arc to put in here. Now the metal point of your compass, when we swing that, will be resting somewhere on this line. Now, how do we find that radius? It's not given, but what it does tell us is that those red lines going to where you'll put the metal point of your compass are perpendicular to the straight line HLG. So we put down that there, It'll go slightly up into our elevation, but that is the point where we put down our compass, and we'll be able to finish in this guy here. And we'll mirror it down the other side now as well. So I just had to stick in a bit of paper there because I want to mirror this down to get the arc on the other side. And I've just run out of paper there on the bottom. So this will be the same now as the top side, just mirroring it down. We're going to recreate that arc there. And that's it, almost finished in. We have to go back to this line now, just where the road went under it. And with a bit of hidden detail to put in there. The same on the top. And that is your plan and elevation finished there, folks. Now, there's one last part in the question there, which is C. And it asks us, in elevation, the focus of the parabola ABC is located 4.9 meters from vertex B. Locate the focus and draw a line which is tangential to the parabola at a given point C here. So 4.9 is 49 mil. So that's our focus. This is our vertex. B is our vertex up here. Now, one way of doing this would be to find the directrix, and we can do that very easy, because with a parabola, the distance from the vertex to the focal point is the same as the vertex to the directrix there. So we can take that distance there, and we can draw in our directrix, DD. And we know that our parabola has an eccentricity of 1:1. So I can put in my eccentricity line going off there. And I know one way of putting a tangent on that is common to all three conics is if I want to put a tangent in, I can draw a line from and that point that I want to put the tangent on to the focal point. Get my other set square. And if I go off at 90 degrees to where it hits the directrix, this point here now in the directrix will let me set up the tangent that I want. And your tangent will come in like that then. And so that's that question finished, folks. Hope you found that video useful. More videos to come. Take care and stay safe, folks.